In this experiment, we are going to try to understand how strain gauges work. If you look closely at the strain gauge provided to you, you will notice that it is nothing but a thin metal grid, and we use this to measure strain. The strain gauge is bonded to the surface of a component on which we want to measure strains, and that is done using some kind of adhesive. When this component is subjected to some loading which induces strains on the surface, those strains are transferred to the strain gauge, and it causes the metal, the foil, to change in length and cross-sectional area, and the change in electrical resistance, which depends on the length and the cross-sectional area, is what helps us measure the value of strain. So the electrical resistance in this foil grid changes as a function of the strain induced by the applied load. And we can measure different physical quantities using different orientations of strain gauges and transducers. We are able to measure pressure or force. We can also measure displacement and acceleration and many others, depending on how we use the strain gauges. So how do we measure the change in resistance caused by some strain? For that, we use a Wheatstone bridge, which is what I will talk about next. Okay. So the change in resistance from a strain gauge is measured using the Wheatstone bridge, which gives us the output in terms of a voltage. If you refer to the diagram in your manual, you will see that the Wheatstone bridge consists of 4 resistances. And anytime there is a change in any one of the resistances, the output voltage changes in proportion. So you are going to look at 3 different cases. The first is a quarter bridge, where the strain gauge is connected to one arm of the Wheatstone bridge, and the other 3 arms consist of resistors to maintain equilibrium. In the second case, you will look at a half bridge, where you have 2 strain gauges connected to arms 1 and 4. And this kind of configuration is typically used to cancel out the effects caused by changes in temperature. Finally, you will look at a full bridge, in which there are strain gauges connected to all 4 arms, and the setup that you're going to use in lab consists of strain gauges connected to 4 different components. These gauges could have been connected to one single beam, where there are 2 gauges on top and 2 on the bottom. But the purpose of comparing the results from a quarter bridge to a full bridge is to look at how the sensitivity changes. So please compare the values you get from all 3 different configurations.
Introduction of the basic operation for TC32K. There are 3 buttons, F1 for proc init, F2 for channel settings, and F3 for to menu. At the beginning, press F3 button for to menu. The first option shown in the screen is program, and then press the ENT button in the bottom right side. The sensor mode becomes the first option, and press the ENT button again. There are 20 channels that could be used for this device, from channel 0 to channel 19. When conducting the quarter bridging experiment, we use 0-1 channel to measure data. Press the ENT button, then choose 1G 3W 120 ohm and press ENT again. If we want to leave, press ESC button 3 times. The second setting is for changing the unit. Press F3, choose Program, choose the second option, CoF digit unit, and then press ENT. Select the channel which we will use for this experiment, and press the arrow-shaped button. For this experiment, choose 01 channel. Using the right arrow-shaped button, we can change the display digits and the decimal digits. For changing the unit, we need to press the right arrow-shaped button until the end of the options, and then press Enter. Select MU, press ENT again, and then press ESC for leaving. For changing the correctness of the previous setting, press F2. Press 0 and 1 for examining channel 01. The screen should show 1G 3W 120 ohm basic information. Then connect the wire to the correct position. Follow the graph above the device about the quarter bridging instructions. 2 wires should be connected to point A and B separately, and there is no difference about positive and negative for these 2 wires. For point B and C, use short wires to connect each other for making a short circuit. Please press the button for locking to avoid cutting the wires. If all the wires are connected correctly, measured values should directly display on the screen. The following instruction is about how to reset the measuring values to 0. Press F1 for proc init. Select the first option, initial in, and then press ENT. Press the left arrow-shaped button. Choose OK and press ENT again. Introduction for how to manufacture the specimen and paste the strain gauge. This is an experimental device to simulate the cantilever beam. This is a fixed end, and the length for the fixing zone should be 4 centimeters. Please follow the instructions from the TA about the position for pasting the strain gauge. This time, 5 centimeters is from the edge of the fixed region to the center of the strain gauge. 4 centimeters for the fixed zone and 5 centimeters for the center of the strain gauge. Use a pen to scribe the plus sign for representing the position of the strain gauge. When conducting half bridging and full bridging experiments, please set all devices to have all the same length of the fixed end zone, 4 centimeters, and the strain gauge position of 5 centimeters. Draw the plus sign at the 5 centimeter position. This section is to introduce how to paste the strain gauge. The metal surface should be clean. Get a sandpaper from the small plastic box. The sandpaper should be used on only one direction to mill the metal. Use the alcohol to remove the oil and dirt on the metal surface. Use one way for cleaning. Use the super glue adhesive. Do not let the super glue stick on your hand. If the super glue is suddenly stuck to your hand, please open your hand immediately. Prepare the tweezers and then apply super glue adhesive on the plus sign marked. Get the strain gauge. Remember that there are two different surfaces of the strain gauge, the epoxy resin surface and the metal surface. The metal side is facing upwards. The ends of the metal wires are facing outwards to be prepared for welding. By using the tweezers, we align the strain gauge to the plus sign. Take a transparent plastic sheet from the plastic box and then put it lightly on the strain gauge. Use our thumb to press on the sheet for 1 minute. After 1 minute, slowly remove the plastic sheet. Lift the plastic sheet slowly and carefully. Use the tweezer to pull up the pins of the metal wires gently. Do not paste the pins to the metal surface and do not break it. Use the insulation tape, and its length should be around 3 centimeters. Paste the tape to the position of the metal pins and the downward side of the strain gauge. Use the sandpaper and alcohol to mill and wipe the surface. For pasting the metal alloy end, apply the super glue adhesive. Use the tweezer to clamp the metal terminal. There are two different surfaces, the epoxy resin surface and the metal surface. The metal surface is facing upwards. Using the plastic sheet, press down on the metal surface for around 1 minute. Pull up the plastic sheet lightly and carefully. Must keep the two metal pins apart and do not let them generate a short circuit. Apply the appropriate amount of soldering tin to the 4 points for welding. Use the tweezer to weld the metal pin to the metal terminal. Weld the other metal pin. Deal with the red metal wire. Separate the wire to 2 electrical wires. Strip the plastic outside coating of the wire by using the diagonal plier. Because one wire can have many cores, it can branch easily. By welding, we can generate one single wire. After we finished with the welding of the wires, we can now connect to the TC32K more easily. If the wire is too long, it needs to be cut to 3 millimeters in length. Weld the 3 millimeter length wire to the metal terminal. After welding all the wires, we need to examine the resistance by using the multimeter. Original information from the company states that the resistance should equal to 120 ohm. Use the transparent tape for insulating. Cut 3 tapes with the appropriate length. The first tape is to be pasted on the strain gauge. The second tape is to be used as the insulation layer to protect the metal bare wires. The second tape is to be used as the insulation layer to protect the metal bare wires. The third tape is to be pasted on the metal terminal. Measure the resistance again by using the multimeter. It should still be 120 ohm. From now on, we are going to conduct the quarter bridging experiment. Follow the instructions. Point B and C must have a short circuit. It means that the point B and C of TC32K 1G 3W need a short circuit. At first, we need to have one metal wire. After the metal specimen is installed on the device and the fixed end is set as fixed, if the red knob is turned clockwise, the strain gauge should be under compression. If we want to measure tensile force, the direction of metal specimen needs to be changed. When we install the fixed end, it must be correctly aligned. It is very important that the length of the fixed region is 4 centimeters. Therefore, it needs to be locked tightly. However, the specimen of this direction must be kept horizontal without tilting up. The red knob needs to be turned clockwise to connect to the metal specimen. When the pointer of the displacement transducer starts to rotate, it means the specimen is really connected. Then we can reset the measured value of the displacement transducer to be 0. One unit for the outside circle of the displacement transducer is 0.01 millimeters. Every time, the pointer of the displacement transducer needs to turn 50 units. Now connect the metal wires to point A and B. For quarter bridging experiment, point B and C need to have a short circuit by connecting each other with one metal wire. Press the power button to turn on the TC32K. At first, reset the measured values to be 0 for the displacement transducer connected to the cantilever metal specimen. Second, reset the measured values of TC32K to be 0. Now, start to conduct the tension test of the strain gauge. Rotate the knob clockwise until the displacement transducer turns 50 units. This is the half bridging experiment. The recording table is in the middle part. The upper table is for tension. The lower table is for tension compression. Now, this side is for tension, and that side is for compression. TC32K should be changed to 2G mode by following the previous instructions. Follow the graph instructions. The wire which was used to generate a short circuit for point B and C needs to be removed, and in the same position should be replaced by the metal wires from another experimental device. Now, the knobs of both the experimental devices need to be rotated to touch the metal specimen. Reset the measured values of the displacement transducer to be 0 at first. Then reset the measured values of TC32K to be 0. Follow the instructions on the recording table. Rotate the knob until the displacement transducer turn 50 units for both experimental devices. Then, finally, the measured experimental values will be the same as the quarter bridging test under 100 unit tensile force of the displacement transducer. Now, begin to conduct the full bridging experiment. The recording table is on the right side. The 4 devices for the Wheatstone bridge test are installed as follows: connecting point A and B, connecting point B and C, connecting point C and D, and connecting points A and D. Set TC32K to 4G. Both the devices installed at points A and B and points C and D are under tensile force. Both the devices installed at points B and C and points D and A are under compression force. All the measured values of the displacement transducers need to be reset to 0 for the cantilever beam experiments of those metal specimens. Reset the measured values of TC32K to be 0. Follow the instructions in the table to conduct the experiment.